초콜릿은 달콤해 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 오렌지는 상큼해 상큼해 상큼해.
Polar coordinates. History of polar coordinates. Greeks used the concept of angle and radius. Hipparchus tabulated a table of chord function giving the length of the chord for each angle, and there are references to his using polar coordinates in establishing stellar position. Archimedes describes his famous spiral, a function whose radius depends on the angle. Saint Vincent introduced the concepts about polar coordinates privately in 1625 and published in 1647. Cavalieri published concepts about polar coordinates in 1635 with a corrected version appearing in 1653. Cavalieri first utilized polar coordinates to solve a problem relating to the area with an Archimedean spiral. Blaise Pascal used polar coordinates to calculate the lengths of parabolic arcs. Sir Isaac Newton, in Method of Fluxions, written 1671, published 1736, was the first to look upon polar coordinates and 9 other coordinate systems. Jacob Bernoulli used a system with the point on line, called the pole and polar axis respectively. Coordinates were specified by the distance from the pole and the angle from the polar axis. He extended to finding the radius of curvature of curves expressed in these coordinates. Gregorio Fontana was accredited the actual terms polar coordinates and used by 18th century Italian writers. George Pickax. The term appeared in English in 1816, accredited with the translation of Lacroix's differential and integral calculus. Alexis Clairaut and Leonard Euler are credited with extending the concept of polar coordinates to 3 dimensions. Properties of polar coordinates. In mathematics, the polar coordinate system is a 2-dimensional coordinate system in which each point on a plane is determined by distance from a reference point and angle from reference direction. Polar coordinates describe a point in space as an angle of rotation around the origin and the radius from the origin. Cartesian coordinate to the xy components of a vector. Polar coordinate the magnitude, length, and direction angle of a vector. The Greek letter theta is often used to denote an angle, and the polar coordinate is conventionally referred to as r theta instead of x and y. Sine theta is equal y over r, that's y is equal r sine theta. Cosine 0 is equal x over r, that's x is equal r cosine theta.